Welcome to another episode of GreenChat. Today we have a distinguished panel. We have Professor Satya Chakravarthy, 1991 alum from IIT Madras. He did his aerospace engineering here and then did his master's, PhD and postdoc with Georgia Tech. Then he became a faculty at IIT Madras. He is from Alag. Then we have Dr. Subramanian Kanakasabapathi. He is 1995 BTech in mechanical engineering from IIT Madras. Then he did his PhD from Cornell University. He then worked with GE and then with Power Gear. Currently, he is the Senior VP of Product Development at Ashok Leyland. We also have N. Suresh. He is one of the creators of this GreenChat, and he's been with us earlier. You've seen him in earlier episodes. Global CO2 emissions from transportation, as you remember from the last episode, is 24% of the whole energy contribution, with a big chunk of it coming from road transportation, passengers and freight, and aviation and shipping making up for the rest. In order to reduce these carbon emissions and its impact on global warming, several scenarios have been developed, and we talked about this scenario in our last episode too, where we need to do two main things. One is increase the efficiency of the current vehicles. And secondly, we have to develop new zero emission solutions. And in this episode, we'll be talking about both these aspects from vehicle technology perspective. As many of us know, several governments have already announced plans to phase out ICE-based engines for passenger vehicles. So that sector is fairly there. The technology seems to be there for passenger vehicles, two-wheelers, three-wheelers, and it's a deployment question. But for other modes like heavy truck, shipping, and aviation, these are at early stage. So they are either in the prototype stage or in the demonstration stage. And very few of them are at a mature stage. So let's welcome our panelists and talk about the various issues in decarbonizing these sectors. So the first question for all of you is, what is the current fuel of choice for different types of vehicles, and why are we going with those vehicles? Satya, do you want to start out?
So when you now say different types of vehicles, so let us first of all categorize them. So I think I think as you had mentioned, the 2, 3, and 4-wheeler passenger segments, there is credible, implementation of electric vehicles right away. Of course, I think the jury is still out on what's going to be the environmental effect of a large-scale adoption of battery electric vehicles, right? So, including the recycling of batteries and what's the carbon footprint associated with that. So that's a separate topic, right? Particularly if you're now looking at the fuel choice, I think it makes sense to actually talk about the heavy-duty trucks, the things that are not exactly passenger vehicles on the road, as well as if you want to think about trains and then other things like aircraft and shipping and so on. From that perspective, to me, it seems like, again, if you come from the large vehicles, right, coming back down, hydrogen seems to be something that a lot of people actually favor, but I'm not seeing that being adopted very quickly because there is production problems, there is storage problems, and transportation of hydrogen, safety. Lots of those things have to be addressed about hydrogen. And then again, you have to actually ask, would you use fuel cells for it, or would you actually directly burn hydrogen and so on? So it could be probably done with like larger vehicles because we need to have like larger tanks and so on, but not expecting that to come down to smaller vehicles. So I think that it's important for us to actually be seriously thinking about natural gas as well as methanol. If you think about those two, they are actually a single carbon, choice where, it can directly convert that to CO2 and look for how the CO2 can be recycled back to, methane or some kind of natural gas and or methanol. There are people who actually think that you don't necessarily have to get rid of all of the CO2. You have to actually work on getting rid of some of the CO2, maybe with afforestation. But at some point, you can actually maintain an equilibrium of CO2 in the atmosphere that's acceptable. And from that perspective, actually having a single carbon solution to a single carbon problem, maybe actually a more intermediate solution. So I would say like natural gas, methanol would make more sense. Of course, people are also thinking about ammonia. That's another option. So these are.
What about aviation industry, Satya? I mean, what's the
The
fuel of
aviation industry
choice?
is going mainly towards hydrogen, but they expect that, I think the earliest they're expecting anything to happen in the aviation industry as we know it today is by 2035, right? Not sooner than that. This is actually someone like Airbus that is putting out those kinds of dates, but there are other major startups like Zero Avia that are probably betting on hydrogen sooner. But that is for like smaller aircraft, maybe not really the kind of the aviation aircraft that we are familiar with. But that said, I think there's a huge amount of work that's happening on electric aircraft at the smaller scale, which could be meant for more like eVTOLs for urban aerial mobility. So that would be a new kind of aviation that we are not used to yet that will come up. So this is actually what's happening in the aviation side. But primarily, it's all predicated on hydrogen if we're thinking about a fuel choice.
Okay, Subra, do you want to?
Yeah, sure. Again, to start with, thank you for inviting me to this great honor to be on a stellar panel. So I think Satya said it just right. For heavy vehicles, it's pretty much diesel today, which is running in the majority of vehicles. But as Satya said, there's a lot of shift happening to CNG, which is compressed natural gas, and also its close cousin, which is LNG, which is liquefied natural gas, because once you liquefy it, it's not under that high of a pressure anymore. So it's a little easier to store. And you can actually get a much longer range because you have effectively more fuel in the vehicle. And then the shift to hydrogen, which depends, of course, on so many different factors. Hydrogen, again, can be used in two ways. You can burn hydrogen directly in an IC engine, with a lot of changes to the engine, of course. The catch is you're also burning air. In other words, you're producing nitrogen oxides, which means it's not exactly clean. But then engines can be tuned to reduce that, and you can do after treatment and all that. And of course, hydrogen can be used in a fuel cell, which is a much cleaner solution and also more expensive. So there's a lot of trade-offs happening on the way to electric. Not clear which is actually workable for a country like India. Hydrogen could be workable, but it depends on a lot of factors: government policy, infrastructure players, and of course OEMs like Ashok Leyland, who I work for. So that's the short answer.
Suresh, from a shipping perspective, what's the current fuel of choice and why?
Greetings to everybody. Well, shipping, as you know, has been today, if you take the statistics, it's 99% runs on fossil fuel. Data based on 2018, 79% on heavy fuel oil, almost 16% on marine diesel oil, and 4% on LNG. But the trend is now going more towards LNG fueled ships. That's a trend which is going to happen. Further going forward, it looks like LNG could be the transition fuel, wherein hydrogen and ammonia, once the technology is matured, might become the main fuel for this sector. But if you really look at the sector now, shipping is not in isolation. Now, shipping is something like 100,000 ships running the world, supporting an economic trade value of almost $20 trillion. So there are a lot of players, parties. Like there is a lot of pressure on shipping to decarbonize it from the charterers, from the financiers, from the insurers, and the regulatory bodies already on top of it. But then they need to depend on the designers, on the shipyards and the OEM manufacturers to support them with that kind of a technology for decarbonizing a ship. Again, relating with the cost of the fuel, what they're going to choose, and the kind of capex, what they're going to incur for retrofitting or for new building. So this is the scenario as far as shipping is concerned currently in the fuel.
If you look at the three sectors, what are some of the low-hanging fruits in terms of vehicle technologies for low carbon? I mean, we talked a lot about CNG, we talked about LNG, but what are the implications in terms of efficiency as well as the emissions? Because we are still, CNG to a large extent is fossil fuel and it's methane. So, I mean, how are we decarbonizing it and what's the low-hanging fruit here?
So yeah, I think as I said, change always actually happens with some continuity. So from a diesel, petrol / gasoline economy, I think if we have to actually go all the way to something that is totally green, it has to transition through a whole bunch of other fuels, and that's a pain because it's difficult to actually make engines and the infrastructure all of that stuff for every new fuel that you want to come up with every couple of years. That's not how it works. So we have to actually do what's doable within a short time frame. So I think that we will actually be going more towards things like natural gas, either CNG or LNG. That's one big option. I think.
What about X-fuels and electro fuels and all of these that are, at least the aviation sector is using?
Cost is one big issue for anything. For example, even biofuels, I think it's not so economically viable. So people are actually looking at bioethanol or something that is mixed at like about 20% level, not really all the way going to transitioning to full biofuels for that matter, right? And it spawns its own problems. Like you have this food versus fuel question, land use for growing biofuel crops, and what its life cycle and so on. So to me, it seems like we have, if you have to keep things simple, we can go in two directions. One is progressive electrification of vehicles, right? And solve the battery life cycle conundrum on what its carbon footprint is on the one side, right? So for example, charging electric vehicles with more solar and renewables, for example, right? Don't burn coal to charge them, first of all, and then look at recycling batteries, new chemistries that are more carbon friendly. All right, so that is actually one path that we need to be going towards, right? Progressively electrifying more and more vehicles, larger and larger vehicles, and so on, which is actually not so easy. Again, will take maybe 10 to 20 years to get somewhere there. On the other hand, if you are looking at the fuel-based economy, then we definitely need to transition all the way to hydrogen. But I think the path to hydrogen will take place with smaller carbon molecules, which is like either natural gas or maybe methanol, with people dabbling with ammonia as a representative of hydrogen. As a matter of fact, methane or methanol or natural gas is also sort of like a hydrogen carrier. So ultimately, it's all going towards hydrogen. But if you use combustion technologies, you have to actually focus on low NOx is one issue. So in the 90s, people were actually talking about a lot of NOx related problems, but they were stepped off their feet when people basically said you can't even burn fuel because it's producing carbon dioxide. So right, so a lot of the debate has actually shifted to like something that is very, very basic. Can we burn it all? Right. So, but there is like a lot of good low NOx technologies that can come up. From an efficiency perspective, you would tend to think that fuel cells are actually better, right? From that perspective, but fuel cells are actually still too expensive, and they require like high purity hydrogen most of the time. And so those things are actually going to be sort of impediments to adopting fuel cells in the near term. So the question is like, what about combustion? So IC engines probably, if you're burning hydrogen, could probably get about 44%. I'm not an IC engines expert per se, but there are gas turbines that are showing better promise of efficiency. And the question is like at what level, right? So larger gas turbines are more efficient, can approach people like GE claim up to 60% efficiency, which is sort of really on the higher side for any internal combustion processes. We are there. I mean, I think between the conventional combustion versus fuel cells, I think fuel cells actually have a higher efficiency promise, but we can actually get both of them to be there with low NOx implementations and so on. Question is all about cost. I think how to bring down the cost of any of these new things is really the catch.
I just want to add one more angle to it, like heavy vehicle. I mean, is there more other than fuel technologies and combustion? Are there any other low-hanging fruits to improve the efficiency of the vehicles?
Yes, yeah. So I think you hit upon the point exactly, and this is one of my favorite topics, because if you want to innovate on something as big as a low carbon, zero carbon challenge, I really believe that you have to go back to the fundamentals, because we've been making certain assumptions for the last 200 years. And if you go back to Newton's time, right, and I'm saying Newton because he was the first person who defined the equation for moving objects. And F equal to ma, right? So force equal to mass times acceleration is pretty much what defines any moving object. And everything else, in a sense, is derived from that, right? So if you look at that equation, I'm going to actually use that equation to challenge even the core idea that it's all about fuel. Because as you rightly asked, I think there are other low-hanging fruit well beyond fuel. So if you look at F equal to ma, there are only two parameters in that equation. One is the mass, right? So the weight of the vehicle is a serious issue. And even today, if you look at the periodic table, we hardly use just a handful of elements in the periodic table. Almost the majority of the elements in the periodic table are still left unused or is left for very, very niche applications.
That's just for us to mug up for the. That's just for us to mug up for the test, Subra.
Exactly. Yeah, and we all did mug up, and then what did we do afterwards, right? So it's pretty much steel and a little bit of aluminum here and there, right? So there is so much to do on materials, and therefore lightweighting, which speaks to the M term, the mass term. Right. And if you look at the other term to me, which is more interesting, right, it says acceleration, which means that only when you have acceleration, there is a force, right? It's a very simple outcome of Newton's law, which means if there is no acceleration, there is no force. And force times distance is the energy consumed. And I'm talking first order, if you just ignore other losses for a moment. So first order effect, only when you accelerate is when you consume energy. Right. So that force times distance, that distance is not the distance that you travel, it's the distance through which you accelerate. Right. So if you were to travel, let's say from Chennai to Bangalore, which is about 350 kilometers, what Newton is trying to tell you is you can accelerate once in Chennai, let's say 0 to 80 kilometers an hour, which will take you what, 30 seconds, 1 minute max. Right. The rest of the journey from Chennai to Bangalore, assuming there is no traffic, etc., could actually be free, because if you don't accelerate, there is no force. You maintain a constant speed, there is no force, and therefore there is no energy consumed. So the whole notion of a unit like kilometers per liter, or for the electric equivalent being kilometers per kilowatt hour, the whole unit, in my opinion, is not right, because the number of kilometers you travel is not actually related directly to fuel consumption to first order. Right, so I want to challenge the basic notion. So it is that the fact that it is fuel that is carrying you distance, because in Newton's law, F equal to ma, distance is not part of the equation, right? It's actually acceleration. So it's how often you accelerate that actually determines how much energy you consume, right? And again, I'm talking first order. We'll come to second order effects, right? So if you were to do simple things like if you were to limit acceleration. And all of this is possible because there is more and more electronic control in any kind of vehicle, whether it's a passenger car or whether it's a heavy truck, right? A lot of the control is now shifting to electronic. So for example, if there's a vehicle in front of you and if the driver wants to give a pickup, you know the driver is going to brake because there's a vehicle in front, right? And the controller could figure this out and prevent the acceleration and therefore the consequent braking. And braking is kind of the same as acceleration, because every time you brake, you need to accelerate again to come back to your original speed, right? So if you tackle this effect where you reduce the mass, you significantly reduce acceleration, right? I think that will speak to a significant improvement in mileage. Because as I said, it's not the fuel consumption that carries you the distance. It's actually the acceleration profile, right? And therefore the braking profile, right? So better roads, no toll gates if that is possible, better traffic management, just all of this so that you don't need to brake and reaccelerate. Right, I think that alone will be a huge master volume kind of control, which will amplify a lot of efficiencies. And second order effects is what actually is dependent on distance, which is the rolling resistance of your tire, certain friction losses, and certain air resistance kind of losses. And these also should be tackled. But if I were in this, and I am in this field, I would tackle the first order effect first, and then come to the second order effect.
I want to quickly respond to what Subra said. On both the M and the A. So, as an aerospace engineer, the M comes actually very natural to me, right? So, I didn't even think that we need to talk about it, but I think if you're an automobile engineer, yes, I think it makes sense to talk about it. So, for example, aerospace, we actually have shifted to carbon composites for a long time. It doesn't have to be even carbon composites, could be even like glass fiber, right? I don't even know why they're using metal, right? So, a lot of things about automotive, I just have no idea why they are actually doing what they're doing, because it just doesn't make sense to me. I can say this as a professor. Right, and similarly aerodynamics, right? So there is like about a 80% drag reduction possibility on current automobiles, right? This is including even the Teslas and all that stuff, right? So that's coming out newly, and I don't even know why they don't do it, right? So I think automobile industry is like about 100-year-old industry, and they just move extremely slowly. That's what it seems like. Aerospace too, right? But they figured out that you need to have better lift to drag ratios and all this stuff long back, and we make incremental progress over what was actually found to be something great. But a lot of what Subra said actually points down to Hyperloop. Okay, so essentially
we will
meaning
get
that,
to that.
right?
We
So
will get to
I
talking
was like,
about that
I
in
mean,
a
I was
second.
thinking like, is he coming there? Is he getting there?
Yeah, so let's hold that thought. We will come back to it.
I
Let's
think I
hear
just
from
wanted to
Suresh
summarize,
on
saying that we are unnecessarily blaming the fuel alone sometimes, where
Correct.
there are much bigger parameters.
Very good point. Very good point.
True,
Actually.
agreed. So Suresh, from a shipping perspective, what are some of the low-hanging fruits?
Well, there are three areas from the shipping point where we can look at it. One is blending of biofuels, which can reduce up to 20% of carbon emission. That's something. Then the design of the ship itself. Today we are looking at low friction hull coatings, which can reduce friction force. And wake
That's like
equalizing
what,
effect.
yeah, low drag.
Wake equalizing ducts and higher efficiency propellers, which can reduce it by say 15, anything more than 15%, it can give a kind of a reduction. The third one is the digital platform. That is very important now, because if you really see the global supply chain issue, what happened last year, now there is a lot of effort in preparing a digital platform to optimize the complete usage of assets and kind of a thing, which will reduce your complete carbon emission by more than 20%. Now, what this digital platform is going to do is it is going to reduce
that
the
gets into things that are not related to vehicle technologies, right? I mean,
correct.
Let's
it is not
talk
related
about
to vehicle. Okay, it's not related to vehicle technology, but this is how the whole operational efficiency comes into picture in the shipping
right. So
area.
let's talk about operational issues at another time. So vehicle-wise, you're talking about biofuels. You're talking about design of the ship itself to reduce the drag, like Satya and Shubhra pointed out, right?
Yes.
So like moving on, what are some of the evolving technologies? I think we've covered many of these. Are there any specific things that we can do? That are evolving but are not quite out there in terms of maturity. Yes, please. Satya.
Right. So that's actually my space.
Yes.
Right. So we do have a couple of startups that I could actually mention here, which is Aerostravelos, that is developing micro gas turbines for trucks and long distance buses. And it's a fuel flexible engine, which essentially means that you can start with your diesel, petrol, whatever that you get, but through natural gas, compressed or liquefied, whichever way, and go all the way to hydrogen. So we need something like a transition engine, right? And we don't really have a transition engine today. If it has to actually take all these different fuels. That's one of those things that we are developing. And it's essentially a hybrid electric vehicle. So it generates power on board to charge a lean battery pack continuously. That's the idea that we are working on. The second one I would say is another one that has actually come out of the technology at our combustion center that Professor Vinu has been pushing on X2 fuels. That is to actually generate crude oil from unsegregated municipal solid waste. Now, the question basically is that it takes us back to carbon, but one of the things that we are not really talking about is how much garbage are we piling up every day, right? And what do we do about it? And that's a green problem or a anti-green problem too. So I think before we completely transition away from anything to do with carbon, we should promise that we don't throw garbage out that is like particularly plastics and food waste, which is all carbon, right? And if we do, then why don't we use that for whatever little carbon utilization that we need to do on transportation? So that's, I think those are solutions that I would talk about.
Okay. Suresh, do you want to talk about it?
Yeah, see, there are quite a good, nice technologies getting involved in the shipping sector. Now, what there is happening is on the wind-assisted propulsion system, which is getting added to the ship's current propulsion system. So, which will help in reducing taking the power requirement of the ship itself by almost 20 to 40%. It is going to reduce it. The other thing is they are also looking at, from the carbon capture point of view, they're looking at the onboard CCUS system, which can capture the carbon directly from the engine and store it into liquid CO2 form, and then that can be disposed of when it reaches a proper terminal where it can be disposed of. And there is a lot of development happening on the IC engine development for ammonia. And MAN is spearheading it. Mostly 2025, we are going to have the first marine engine running on IC two-stroke engine, running on ammonia, which will be put on a ship, and that will be going. The other area which is being looked after is nuclear-powered propulsion. So now there is a new technology, molten salt reactor technology, which gives you the power requirement from 100 kilowatt to 1 megawatt kind of a thing, which is being tested, which is being in the construction now and likely to come into the fray in the industry around 2030 kind of a thing. So this is where the new technologies which is happening, and also on the battery hybridization thing, they're looking at how we can go on a short range kind of a travel on the ship side, basically. So that's a technology they're waiting for it to come up with it.
Great. Subra, what are some of the things?
Once again, I can't resist the temptation. Go back to the fundamentals. So I think to me, the second law of thermodynamics, right? What it tells you is that if you convert any kind of energy to heat, then converting it back to something useful, to useful work, is actually very, very difficult, right? So heat is like the poor man's form of energy. Why? Because second law of thermodynamics tells you that entropy is in general a bad thing, and the heat is an avatar of entropy. So because it's just random motion, right? I'm oversimplifying a little bit, but I think this is the essence, right? So any technology to me that converts chemical bond energy in the fuel to heat first, and IC engines, we are equally guilty of it, right? I think any technology that you convert to heat first and then try to extract work, I think is fundamentally limited. So that's where fuel cells win. And I'm not saying I'm supporting fuel cells entirely because they have other issues, but fuel cells convert the chemical bond energy directly to electrical potential and flows a current. There's no heat step. The heat happens in a fuel cell because of the inefficiencies and some of the waste that comes up, but it's not a fundamental heat-based process, right? So to me, if we think along those lines and technologies that avoid the heat step, the energy conversion, I think will be the winners in the future, which is one of the reasons electric vehicles are doing well, because there is no heat or intentional heat in the process. You're charging a battery, which is electricity to chemical, and then chemical bond energy back to electricity. Right? And fuel cell is also at heart a battery. It's a very similar technology, right? So that's my 2 cents. Thank you.
Great. So are there, so traditionally we've been talking about 4 modes of transportation: air, road, shipping, and so on. Are there alternative modes of transportation? Satya, this is your clue to talk about Hyperloop, and what are some of the newer modes of transportation we can think about to reduce the carbon footprint?
Right. So, all through, the technological development that has happened, let's say, in the last couple of centuries, we always are, there are 2 things that happen. One is we always think that we need to actually pay a greater price for a greater comfort, right? That's a general thing. But there is somebody who actually comes and disrupts that and says, no, there's a technological alternative that will give you the same comfort for a lesser price. And then, then you go into this thing like greater price for greater comfort and so on. That's what Hyperloop actually tries to do, which is to basically buck the trend and say, hey, if you want to go at like very high speeds, it doesn't mean that you need to actually burn a lot of carbon and cost the planet. We will actually do it at carbon negative, right? It's not even carbon neutral. We want to actually do it carbon negative. So that's a kind of like technology disruption that we're talking about. I would actually want to go back to the basics and not the second law, because that's where actually you can plug in formulas, but the first law, right? Which is being used only for actually cracking your tests and mugging it up, right? So Hyperloop actually uses the first law, which essentially means that if you can remove all friction, right, you just give it a kick and it'll just keep going. No, right? I mean, at least in theory. We have actually done a lot of calculations to make this look very, very attractive. So we have enough real estate to put all the solar panels required for the power that needs to be generated. There is still, and there is actually grid power that we can put in for, what should I say, on the tube or on the track propulsion. So for the first time, we will now remove the propulsion from the vehicle and put it on the track to give it a kick. And that can actually come from the grid power, which balances the solar versus what's the demand supply equilibrium. So all put together, I think Hyperloop actually makes a lot of sense, even for a country like India, or more so for a country like India with kind of a mass transit. When we look at the Chennai-Bangalore traffic that's happening, if you look at all the upper class trains of the flights that are happening, the Volvo buses that are running, all those things, the luxury buses, not trying to advertise Volvo here, right? So, so all of that, if you put together, there are about some 30 to 40,000 people. I'm discounting the lower classes and the normal buses, right? So there's like a lot of people who are actually traveling between, let's say, Chennai, Bangalore. And the Hyperloop can immediately double that capacity through this decade for a country like India. So it is a mass transit. So we call it the intercity metro, right? So we want to essentially go from Chennai to Bangalore in 15 minutes, like how you would want to do within one city, right?
I can't even get to the airport from
exactly. So you don't need to go to the airport
minutes.
anymore, right? So you will actually go from downtown Chennai to downtown Bangalore. Forget about the airports.
Right. So what's the efficiency of Hyperloop like?
Yeah.
So that's hard to calculate because we're still figuring out like how to calculate the efficiency as such, because you have the electromagnetics, which I think today the propulsion part of it, you can achieve up to about 70% efficiency. And levitation, very similar number. So there are a couple of things that happen. Then there is vacuum that is actually consuming power. And then there is a trade-off between what speeds that you want to go to, what should be the tube size versus the pod size, so that the annular gap through which the air flows offers the drag at a particular pressure, right, that you are evacuating up to. So there is no quick answer to this right now. I think there are papers that are still crunching these things, but fundamentally it's all mostly going to be electric, which means that we can expect like fairly high efficiencies.
Great. Suresh, you are working on something in this space too.
Yes. I am working on freight movement. Basically, that company where I am working on along with is UMendes Technology. It's UME and Technologies. What we have done we have developed a technology which can move freight on electric power on automated bots kind of thing from point A to point B on a very high scale. That means like one lane of this particular technology can replace 24-lane road. That's the kind of a capacity it has. And it goes at an average speed of, for Indian conditions, we have designed it to go at an average speed of 100 kilometers per hour. Whereas for other countries, we can design it for higher speeds. And the advantage of this technology is you don't need a big land footprint at all. It's just 1.2 meters is what we need for running this kind of a technology. And this runs on total electric power. So the carbon, 90% of the carbon emission is totally cut down. Why 90% now is basically because we have to interface with the current technology in the ports. And so there we have to use some of the current assets and things. So that's where the 90% part comes out. And the other thing is the efficiency part. It removes the bottleneck from a port perspective. What happens is you can't keep building ports as the capacity is overburning. So this and the capacity constraint in a port is the storage area. So now this technology removes those storage area capacity constraints. So directly from the berth, it comes into the hinterland to the design area. So it actually removes the complete truck movement. Currently, if you see India's almost like 70% or 90% of the trade which happens through ports is the first leg is done by the trucks mostly. So this completely removes that particular thing. In India, the traction is okay. On the technology part, we have already got the patent for this technology. We have got it validated for technical and commercial viability by the ADB and the PwC through Department of Logistics in the Government of India. Now we are discussing with various ports to try to see how we implement it. That is, in the Indian scenario, is more on capacity addition for the ports, what it helps. But in the global scenario, it is more of decarbonizing the complete movement of cargo. So that is what this technology is going to do. So there's a new technology which we have developed it in India, which is meant for a solution for a global perspective.
Great. Subra, alternative modes of transport.
I think the biggest competition to the transportation industry is actually video conferencing software, which we are using now, right?
Yes.
So 5 people on this call, we could have traveled and then we could have met somewhere, but I think we robbed somebody of revenue.
In fact, given that all of us are in Chennai.
Exactly.
Wow.
Yeah. So really, I mean, so there are new areas of competition like that happening. There are alternatives like this coming out.
I would be looking for teleportation.
Yeah, but I just wanted
Beam
to
me up, Scotty.
Absolutely.
Yeah, I just want to reiterate Hyperloop as well, because just like the point I made on the F equal to MA, that the kick that Satya mentioned was the acceleration.
Yeah.
Right.
So you just do the acceleration to start with, and then you consume zero energy afterwards. So in fact, there is not much meaning talking about efficiency, because if, I mean, you could give that initial acceleration and then you could go forever.
Yeah.
We could go infinite distance, right? So, I mean, there is no concept there. So that really goes into the ideality of Newton.
So which brings me to the adoption part of it. So, I mean, we are developing all these new solutions, new technologies. But if you look at how long it takes to build a vehicle, whether it's heavy truck or aircraft or a ship, I mean, how long does it take to build these and what is the lifetime? And how does that affect the choices we make today?
Right. So I think so one of the things that we also have to ask is, how infrastructure, how capex heavy are these as well, right? So to implement and so on. So that's where actually there are a few things that are happening around the world that we need to take note of. So we should be looking at technologies that are actually sort of like idiot-proof. To get back to Hyperloop, for example, unlike, let's say, high-speed rail, which is kind of like the closest competition that we know of, we don't need to actually have like perfectly parallel rails like what high speed rails require, right? So because you have levitation and you have what's called a stable equilibrium, that means that if you have any perturbations to the surface of the I rail that is causing it to levitate, the vehicle will actually just slightly move up and down. It'll move up and then come down and so on. And similarly, the tube doesn't have to be perfectly circular or any shape for that matter, right? Because nothing is coming in contact with the tube. So it's very important for us to actually look at what's called as fault tolerant designs, which can be quickly done, because the more perfect you want to get is where actually it becomes capex heavy. It's not just because we had to put like a tube all the way, it doesn't mean that it's capex heavy. How perfectly you have to do this, right? So new technologies do not have to be those advanced technologies in the sense of like using some extremely niche materials or extremely perfect machining and all that stuff. That is where that would be the killer. So what we have to actually look for innovation is how do we actually do this in a much more lousier manner? Okay, that's what I would like to emphasize on going forward. Come up with lousy technologies that are easier to implement, right? And that if you have that kind of an approach to this, I think we can crack the code.
Okay, Subra?
Yeah, so I don't have a direct answer to this. What we are doing as an OEM is, see, we are only one piece of the puzzle. We don't know what technologies are going to see light of day. There's too many choices moving forward. We know it's not going to be fossil fuel, but what else is CNG, LNG, hydrogen, electric? So many different options are there, right? So what we are trying to do is we are building a very modular architecture where we can use the same building blocks to build any vehicle. That's the strategy. I mean, it sounds simple, but it's a very difficult thing to implement. Literally the same building blocks. So whenever the market matures, whenever the infrastructure matures, whenever the government policy is clear, then whatever the customer wants, we are ready to build a certain kind of new tech, new fuel, powertrain kind of vehicle and offer it to the customer. And we're also trying to have electronics, which is a big deal today, electronics in common across all vehicles so that we can use software to define what the vehicle is. Right. So these are some of the strategies. So as I said, it's a bit of a tangential answer, but that's at least a certain way to tackle what's going on in terms of what is the lifetime, what does it build, what we do moving forward.
Suresh, from shipping perspective, what do you see?
To answer your question, a ship normally takes around 18 months to 24 months to build, and the lifetime is around 25 to 30 years. So basically, whatever technology we put in for the capex today has to work for the next 25, 30 years without any issues from regulatory bodies and things like that. So that becomes a very challenging part today because we are in a transition phase, and the most optimum plan what people are following is to go for a dual fuel system and try to see that if we can look at for LNG based propulsion system now, which can be later converted into ammonia based fuel system. So that is where the trend is going towards now, but the whole challenge is again on the capex part of it. So how the capex is going to be brought down substantially is where the whole thing lies, and the support what the shipping industry will get from the financing and other areas where they can get the funding for this particular capex which is required to be done. On the technology front, of course, modular construction is the order of the day, and which few of the top shipyards in the world are following it, which is getting adopted into the system in other parts of the world also. So that is going to reduce your total cost, capex cost of the production of a ship itself. So that is going to be the way forward in producing these huge vessels.
So Satya, I have a question related to aviation here. So let's say you make an electric aircraft, and tomorrow better batteries come. How easy is it to replace the batteries without, I mean, in terms of your approvals and adoption of those?
Yeah, that's a very good question. So the way this is actually evolving is that we are cognizant, very similar to what Subra said. We are cognizant of the fact that battery technologies will actually keep changing in the near future. So there is a jargon that is adopted in aviation and maybe in other industries as well called LRUs, line replaceable units. So we would like to actually look at the battery packs as LRUs, which means that we should be able to design a battery pack that is equivalent to a pre-existing battery pack with a new chemistry, and just plug it in and get the higher power and the higher this thing, what do you call energy stored over there. And we would do the same things for like new motors and new propellers and so on. So all these, so except for the airframe. And what is in the airframe is actually the aerodynamics that is built into it and the structures, the lightweight structures. So that is actually a fundamental that takes us back to what aviation is all about. So if you're getting very aerodynamically shaped and lightweight structures done, everything else is actually an LRU. And that's how evolution can become much faster in an aviation setting. However, that said, every change that we make has to be certified. So if you get like your airframe certified with, let's say, some implementation of batteries and motors and so on, and propellers, everything else actually becomes what's called as a supplementary type certification to be done. And so you actually recertify quickly just for the replaced unit, and you're good to fly. So this is how typically it happens. So we can expect fast turnaround times on these evolutions.
Great. So I mean, if you are a vehicle manufacturer or service provider, what is the advice you would give as they're making vehicle technology decisions? I mean, you all talked about modularity, plug and play as new solutions are coming up. But if I am a service provider and trying to think which vehicle, should I invest in battery technologies or should I invest in CNG vehicles? What can you advise me in terms of selecting these solutions today, these vehicles today? Who wants to take it?
I think Subra is the right guy to take it.
I can start this, yeah.
Okay.
It's $1 million question, literally.
Yes.
But I'll start with the latter half, the service part, because that's gaining a lot of traction today. Why? Because people are seeing all these new powertrains coming in, and the question of servicing them, maintaining them, nothing is available today, right? I mean, the service networks are all geared for traditional vehicles, apart from of course, the common parts like the brakes and tires and all that. That's all in common. So the service model is hugely picking up, because now people are saying, don't even sell me the truck or bus, right? Just you run it for me. You maintain it, you charge it if it's electric, you fill the fuel wherever it's available, because we don't even know where the new fuels are available. And you even hire the driver in some cases, right? So, and we'll just pay you per kilometer, right? Because we don't want the hassle of taking care of the vehicle, understanding the vehicle, because the days of tinkering with a typical petrol engine or diesel engine are going out, right? I mean, a lot of fleet owners themselves used to repair their vehicles, just get a few parts here and there, hopefully original ones, but there are a lot of spurious aftermarket parts as well. But it's becoming more and more difficult as we move to new powertrains. So the service model is hugely picking up, right? And if you're a manufacturer, I think just back in the same question of what technology is going to work. So you pretty much have to be ready for everything, because government policy is going to keep shifting based on what makes economic sense, technical sense, policy sense, etc. Also, other huge infrastructure players in the market, what those large companies will set up. Will they set up a hydrogen infrastructure? Will they set up a charging infrastructure? Will they set up a methanol infrastructure? All those questions are up in the air. But the way we are thinking about this is, as a manufacturer, right? I mean, see, it's like many things in India happen, right? When you want to build a house, you don't wait for the infrastructure. You just go find a piece of land and you build a house. And often the road comes later, often the water supply comes later, the electricity comes later. Until then, you have to pretty much fend for yourself. You have a generator, you have a well, you have, you have to put up with the bad road. So in that sense, a lot of industry decisions also are made like that. where you just start selling the vehicle. I mean, if you want to sell an electric truck, you start selling it, and then eventually the infrastructure will pick up, right? And today our customers are telling us, yeah, just give us a charger at our depot and give us enough battery capacity to run back and forth, right? And we don't even need charging infrastructure on the road, on the highways, right? And that's how things happen in India. I mean, right or wrong, that's the practical situation here. So we have to go with that. We just have to keep launching new technologies. We have to ensure that either it's a service model, or at least if you just manufacture and sell the vehicle, there is the basic infrastructure that we provide that we can help the customer run the vehicle. But that's it, right? I mean, there's no other real answer to this question.
Right. So, I mean, shipping, Suresh, you mentioned is like 25, 30 years of lifetime. So, I mean, in that context, I mean, how do you see addressing this challenge, of especially stranded assets and issues around that?
See, the only way forward currently, which is being advised by most of the classification society to the shipping industry, is to go for a dual fuel system. And this dual fuel system, today you might be able to use the conventional fuel, and later on you can shift to the low carbon fuel in the future, because that is going to be the norm going forward. Especially for ammonia, because ammonia is termed to be the lowest priced fuel in 2050, according to a lot of surveys. So that's where the whole trend is going towards in the shipping side. So that's where it is. So only way forward is going for a dual fuel system, and that's the only advice we can give it to anybody who's coming into this for new build or retrofitting system.
So I think one point that I would like to actually make is I think it's a valid point, which is no matter how much preaching we do about decarbonization and all those things, unless we actually have something that's cost effective, it doesn't make sense, right? It will actually be only preaching. So any technology that we come up with has to be cost effective. You can't do this just for the sake of carbon. I think in this part of the world that we are in, where there'll be few takers, we don't want to look great and then say I will buy like an extremely high price, electric car and so on. There'll be only a few people who do that. And I think it makes sense, right? If you are not actually economically disrupting technologies which are greener, you're not doing the job. I think you're not smart enough, right? So we need to actually have very economically viable solutions that are greener. We can't. That is to say, the green actually comes as a byproduct and not the other way, right? So bottom line is always like, what is it in for the consumer?
But you cannot reduce the cost unless you have economies of scale. With some of these newer technologies, it takes time.
All of that stuff is all of that stuff is fine, but you need to be able to show that at some economy of scale, it'll actually make economic sense. That's what I'm trying to say.
Yes, you are right in that. See, the LNG took 15 years to be adopted as an LNG fuel for the ships. I mean, now we are talking about new fuels coming into the system. So it takes time for it, and economy of scale plays an important role in the whole thing.
This is where modularity also helps, because when you have the same building blocks for different types of automobiles, then you will naturally have scale, because whether you make a lot of LNG or not, you're still using a very similar set of parts for other sets of vehicles also. So you will have scale. Yeah.
Okay, so that's one way to address the scale issue. Satya, when we talked about different modes of, alternate modes of transportation, we didn't get into like, short hop, travel within the city or short distances, the road congestions leading to carbon emissions. What solutions can we introduce there?
I think there, in my mind, I'm actually pretty clear that urban aerial mobility is actually the way to go. In the near future, within the next 3 to 4 years, on the outside, we do expect that there will be aerial solutions that will happen within cities. Because the answer is very simple. If I have to actually borrow from what Subra says, go back to the fundamentals. Even before Newton, there are 3 dimensions in the world that we are aware of. What are we doing with the third? That's basically the question, right? So and the civil engineering guys have a sort of cracked the code with like high-rise buildings further and further and so on, going up in the vertical direction. But transportation people are being stuck on the ground, right? So in fact, that also gives me another opportunity to talk about like submarine kind of transportation for intercontinental, travel, that you should be thinking about, cutting across the depths of the ocean and stuff. That's for later. But to answer your question, I think it has to be urban aerial mobility. I'm not seeing any other option.
Great. So you're talking about really, air taxis kind of stuff.
Yeah. So the thing about air taxis, the thing about air taxis is that it's a debate whether like shared mobility is public transport or private transport, right? So instead of actually running a metro, which will be actually running like a very empty rakes in the middle of the night just for like 1 or 2 passengers, which guzzles energy in any form, right? On-demand mobility actually probably could be more energy efficient, right? So you can't imagine like a metro that is flying. So when you're now looking at or a bus that is flying, it has to be cars minimum, right? So that means that you're taking anywhere between like 1 to 4 passengers at a time, which I think is fine because each travel will take only about 5 or 10 minutes, and a capacity utilization of one particular vehicle will be about 5 to 10 times the corresponding ground taxi. So which is actually a very efficient way of doing this and on demand, which means that people will use this only when they require it. You're not just running buses and trains just for the heck of it. So in that sense, I think there's a lot better operational efficiencies with aerial mobility when compared to ground transport.
All right. So finally, what are some of the broad issues in getting to net zero, or anything else that we want to add here in terms of mobility and decarbonizing mobility that we haven't covered here?
I think a quick thought that I would like to say here, sorry for butting in because it's just a quick thought. I think, for example, India sets its goal as for net zero in like 2070. But I have a feeling that we will probably reach that sooner if the momentum actually builds up. I think it's a very conservative target that has been set up. We can get a lot more aggressive than that, and we probably will if the awareness gains, and then we come up with some very cool, economically viable solutions, which are actually in the anvil. So I'm actually a lot more optimistic about reaching net zero sooner than anticipated.
Suresh, any final thoughts?
Yeah, sure. I also agree. I think the efforts are on. The government also hopefully wakes up to non-fuel factors, as we spoke earlier in the conversation. I mean, if you just see the crowding at toll booths, you'll realize how much CO2 is coming out there. And if you realize how much bad roads are causing. So it's one thing to talk about self-reliance on fuel. It's another thing to say, let me correct a lot of the other environmental factors which are creating a lot of emissions, right? I'm using the word creating because literally, I mean, it is not just a side effect, it's a main effect. So that's a big deal. But to me, I mean, a fundamental question that I have is fossil fuel, which nature made over millions of years, we are consuming in about 200 years, maybe 300. So can we get to net zero? Because our rate of consumption is so much higher than the rate of generation, right? And unless we can tap into nature given renewable sources at a very high rate of efficiency, right? Like if we can have a very efficient solar cell, very efficient windmill. Wind is also basically solar because it's temperature difference caused by heating, which leads to wind flow, right? So ultimately it's the sun, which is the giver of energy. So we'll have to find a way to tap that source of energy at a high rate of efficiency. Otherwise, our rate of consumption will always be more than what we can generate, right? So that's, and again, a very basic problem that we need to tackle. And I think if we can hone some thought processes in that direction, it will be fantastic.
Yeah, from the shipping sector, I think the major challenge or issues which is broadly being observed is the supporting infrastructure for the low carbon fuels, because that's very important to be developed in all the ports and areas where the bunkering can happen for the low carbon fuel. That is something which is not coming up in that speed at which it should come up. Only few ports in the whole, I mean, we can count it just 3 or 4 ports in the world which has got that kind of a bunkering facility. So that is going to be a big challenge. Of course, the other thing is the capex of the new low carbon fuel ships. That's going to be another challenge which is going to be a problem. And the other biggest challenge people are facing is the availability of these low carbon fuels in large numbers, because the quantity available for the complete shipping fleet to run is quite huge in numbers. Now only there are some developments happening in Europe wherein they are trying to target almost 1 million TOE equivalent of biomethanol and things like that. So from biomass and biogas kind of thing. So these development needs to happen in tandem and try to catch up with the things. Then only we can look at something substantial happening from 2030, 2035 onwards towards net zero. And that's where it is. Till that time, it is going to be only on transition fuels. I don't see any change in the shipping industry going into any other mode at the moment.
I just want to reiterate. So Hiran, I just want to reiterate one more point about what I think is net zero. Net zero is not about actually removing carbon. It's about balancing carbon. So I think if we are going over the board on how much carbon is there out there that is particularly anthropogenic, we need to aggressively get into things like afforestation with, let's say, drones shooting, seeds and all those kinds of, like, growing 1 billion trees, within 10 years. Those kinds of things actually are pretty good. Things like carbon sequestration, I have no idea what will be the consequence of that. I mean, the world has had a lot more trees than what it has, so it's actually natural for us to go back to that. But things like carbon sequestration, I don't know if it will actually lead to earthquakes or like, let's say, burying carbon dioxide underground and stuff, or will it actually bring about volcanoes? So don't do anything artificial, but you have to actually combat climate change. First of all, on damage control, controlling the damage that's being done. But after we actually get to a point that is appropriate, and there will be climate activists that will actually even question whether we can ever get back in the first place, but we need to be aggressive about that. Once we are there, I think it's all about, like, carbon balancing rather than a carbon zero, right? So if you're producing carbon, how do you actually remove carbon? So that takes us to what Subra was saying. We did 200 years of guzzling all the petroleum that made in millions of years. So I used to imagine 20 years back, is it possible for us to actually make on the spot petroleum? That's exactly what we're trying to do with the waste, right? So if you don't want petroleum, stop producing your waste as well, right? So that's a balance that we need to actually look at in all spheres of what we're doing.
Okay, that brings us to the end of this episode, and we have covered a very broad spectrum of issues, from alternate fuels to efficiency in the materials used for construction, the electronics, and modes of transportation. And we've also looked at some of the practical issues around adoption in terms of modularity, low-cost solutions, and challenges around infrastructure and policy that we'll be talking about in future episodes. With that, I want to thank all of you panelists, Satya, Shubhra, Suresh, all of you. Thank you very much for your time. And for our listeners, thank you for listening in today. Please don't forget to give your feedback, and we will be doing more episodes around transportation, infrastructure, and distribution and policy issues in later episodes. Thank you very much.